Well, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's devops.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your GoToWebinar control panel and submit your question. And we will try to get to as many questions as we can before the end of today's webinar. Also, at the end of today's webinar, we will be doing a drawing for two $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our 2 lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is automating security beyond the perimeter of cloud native apps. Our speaker today is Alfred Chung, who is a senior product manager at Signal Sciences. Hi, Alfred. Thanks for joining me today.
Thanks, Charlene.
I'm going to put myself on mute, let you get right to what promises to be a great presentation.
Fantastic. Thank you very much. So, hello, everybody. Thank you for joining us today for this talk. Just a little bit about me before we get started. So, been at Signal Sciences now for about a year, and I'm on the product team, and I work mainly with our team that develops and maintains our agent and modules. So essentially in charge of our deployment experience, making sure that our next generation WAF product can be deployed on as broad a set of platforms as possible. And I'll have some more details on that later in the presentation, but been in the security industry for about 7 years now, working in product. Worked on endpoint security, worked on vulnerability management, application security, of course. And before that, I was a developer for a number of years. So with that, kick it off with the agenda. So this webinar will be primarily focused around containers and the need to protect containers. So the first topic that we'll cover is how are containers changing application security and why security professionals ultimately need to have a different mindset when it comes to securing and protecting running containers in production. Why app layer protection matters for containers. So we'll drill down into some key examples of exploits or attacks that can occur with your containerized applications and why app layer protection specifically is required to prevent those types of attacks. Where app layer protection is best deployed for containers. So ultimately, adopting the mindset shift that I mentioned earlier or towards the beginning of the webinar, it really kind of leads to how you deploy your application protection for your containerized applications. And then finally, automating container-friendly app layer protection to make the deployment of these technologies as painless and easy for you and your teams as possible. So how are containers changing application security? So what are containers? I'm sure this is review for most of you. But for those who are still fairly new to containers, just know that containers are an application layer construct. They make it possible to package web applications along with all their required dependencies, libraries, and other binaries required to make the application run. And unlike virtual machines, distinct containers can run applications individually and share the same operating system kernel. So that makes them much more lightweight than virtual machines, which of course require their own full operating system. An analogy we like to use would be comparing containers to VMs as if containers were apartments in an apartment building and a virtual machine was a standalone house. So of course, with an apartment building, you can pack more housing in the same square footage. with an apartment building than with a house because of all the shared components, right? So for example, the walls, the roof, the front door, the plumbing, the electricity, and so on. Whereas when you have virtual machines, all of those components, all of that kind of underlying infrastructure, if you will, needs to be replicated per application for each running on each VM. At the same time, so of course, that provides a lot of efficiencies, and again allows you to pack more containers or applications in the same footprint than with VMs. But these shared components can also create security risks. For example, if you reside in an apartment, you can do a lot to protect your apartment, ensure that there are locks on your front door, etc. However, you still may not be sure if one of your neighbors down the hall might be sharing their building entrance key to people who don't live in the building, and thus create a security risk. So the efficiencies and the flexibility that's provided by the shared components can also sometimes create these security risks. So why are containers popular? So I already talked about the resource efficiency. So on the left-hand side, that gap on the right hand of the container diagram is just essentially kind of a crude way to show the resource or cost savings that you get for running your applications in containers. But containers are also very portable. So build, ship, and run is kind of like the Docker mantra, if you will. When you build your application into a container, because that container runs not just the application, but all its underlying required libraries, dependencies, and so on, differences in underlying operating systems and infrastructure that the container is run upon is abstracted away. So this, of course, is a huge boon to developers who in the past ran into issues where an application that ran fine in their development environment suddenly had issues when deployed to production because of differences in dependency versions, operating system versions, and so on. But with containers, all of that is abstracted away, thus allowing you to build a container in your development environment and be rest assured that that container will run as it did in your development environment, in your staging environment, and in your production environment. That portability of containers, though, as well as other reasons, is kind of what's driving this shift in application security mindset when it comes to cloud native and containerized applications. And really, that's because perimeters are disappearing. So in the past, when it came to protecting your applications from layer 7 or application layer attacks, what was most commonly deployed was a web application firewall, which was a technology that was often deployed at the perimeter of your network, ensuring that external attackers trying to launch these attacks to your applications would get blocked at the perimeter. However, perimeters, of course, are disappearing. Container portability is one of those reasons. So, of course, that container having all the necessary dependencies that the application inside the container requires to run can be essentially executed or run anywhere. How do you ensure that that application, no matter where it's deployed to, is secure? Because perhaps you may have a WAF in your on-premise or your local data center, but maybe don't have a WAF deployed in the cloud. And that raises other issues, which I'll get into in a little bit. Third-party integrations, of course, are also causing the perimeter to disappear. Oftentimes, application developers will leverage third-party services and APIs to provide some sort of business logic or data to their application, whether it's mapping data or whatnot. It's very seldom that you see applications be fully contained and totally reliant on services and resources that are on the same network as that application. Of course, working remotely in microservice architectures, again, are further erasing these parameters. And so what's kind of becoming the trend now when it comes to securing or protecting cloud native applications is moving to a zero trust model. So similar to zero trust as it's implemented for enterprise networks, zero trust in the context of application security is similar in the sense that you don't assume trust of a microservice or an application based on its presence within a particular network, but rather on the identity and perhaps even the code provenance of that application or microservice. And this is something that Google actually lays out in quite a lot of detail in a white paper that they released towards the end of 2019 called Beyond Prod, which is sort of their interpretation or their implementation of zero trust for their cloud native applications, APIs, and microservices. And is largely tailored or modeled after their Beyond Core zero trust network security model that was highly influential in the security space. So with that, let's move on to why app layer protection matters for containers. So container breakout is a type of attack that allows an attacker to breach a container, access the underlying operating system, and then from there pivot to attack adjacent containers running on that operating system or adjacent infrastructure. And container breakout is something that is often the result of a container misconfiguration. So some examples of this would be the container being configured to run as privileged, or perhaps it runs as root, or there are dangerous directory or volume mounts giving that container access to critical resources on the operating system. And oftentimes it's through the application layer that the attacker executes a container breakout. So some examples of such attacks would be a remote code execution or command injection or server-side request forgery. So these are all attacks that, if the application is not well protected, could be executed through the application layer, reach the underlying container, leverage a misconfiguration of that container to then gain a foothold on the underlying operating system, and then again, allow the attacker to pivot to other adjacent resources. So where is app layer protection best deployed for containers? Application layer protection or web application firewalls, of course, started out as network appliances used to protect applications hosted in the data center. This is a technology that was first developed at a time when people were mostly working in offices. Applications were all hosted on-premise in data centers, and there weren't as many third-party services and APIs that developers could leverage. As organizations move to the cloud, however, they're finding that they need to keep those existing appliances to protect their on-premise applications. But they're, of course, also exploring the cloud and migrating a lot of their applications to the cloud. So in the case of AWS, they would use AWS WAF. In the case of Google Cloud, it'll be Google Cloud Armor. And in the case of Azure, it'd be Azure WAF and so on. So because application layer protection has historically or traditionally been tied to the hosting platform, whether it's a data center, Google Cloud, AWS, etc., what has resulted is fragmentation, where large enterprises and organizations who host applications in different hosting environments need a different WAF for each of those environments. So put it another way, when you have a perimeter-based application protection solution and your app is or your apps are deployed across different hosting platforms, and you have different perimeters to secure or multiple perimeters to secure. So as a result, you'll get different rule sets for each WAF technology that you're using, different user interfaces and feature sets, and ultimately a disjointed WAF policy that is harder to audit and harder to execute upon, and ultimately leaves you more open to compromise. Because perhaps you may have a team that's really familiar with your virtual appliance WAF, but maybe less so with Google Cloud Armor, and is perhaps having trouble translating the rule sets from their appliance in the data center to Google Cloud Armor because of differences in UI or feature sets, etc. In a zero trust model where your protection is tied to the application and not the hosting environment, and of course, since I work for Signal Sciences, I'll put our logo up here. When you have an application protection solution, a layer 7 protection solution that travels with your application and is not inherently or intrinsically tied to the hosting platform, that gives you the flexibility to deploy that application protection wherever that application runs from, whether that is your local data center, AWS, GCP, and so on. And the benefits therein are it's a single rule set across all those different environments, a single UI and feature set, and ultimately a single unified WAF policy, which will allow you to better execute against that policy and better audit the applications and the protections that are deployed on them. So deploying zero trust application protection with containers. There's a few different ways of doing this. I'll go through some examples. The first would be kind of a RAS type install or runtime application self-protection deployment, where the application protection's actually embedded in the code. So usually this is some library that you include in your application. And when you build your application, that protection goes right along with it. There's also service mesh style deployments of this kind of next generation application protection, where you have your applications run in separate pods within your Kubernetes cluster. And your protection is deployed as a sidecar to the app or microservice in each pod. And you would leverage the service mesh control plane, in this example, Istio, to kind of manage the configuration and deployment of those sidecars throughout your cluster. And then the third method would be deploying the protection at the ingress of your cluster or the software perimeter. So this is a bit different than the perimeter as I was mentioning previously. This is the perimeter of your Kubernetes cluster, and because it's software, it's not something that, again, is intrinsically tied to your hosting platform. It's something that can be deployed to different clouds, to on-premise if you have on-premise Kubernetes clusters, which is not necessarily unheard of. And thus you would still get that same benefit of having the protection kind of travel alongside the application wherever it gets deployed to. So what might it look like in practice? So here we have a diagram. So this example, it's an AWS account, and you've got an EKS cluster running in AWS. Perhaps you've got a Kong gateway kind of fronting your cluster. You've got 2 applications running in containers. You have an inventory matcher and a procurement app. And for one of these applications, you've got a service mesh deployment. Perhaps you've also got a legacy data center as well as a third-party SaaS inventory app that you're leveraging. So these deployments where you see a little 6-eye shield are all different ways that our specific technology can be deployed. Of course, this is going to vary from vendor to vendor, and some of these deployments are redundant. It's not typical for our customers to deploy them both at ingress and also on the application. However, we do have some customers that do that just to get the additional kind of traceability by doing so. But anyhow, so being able to deploy at the gateway layer, so we do have a Kong plugin that can be leveraged, as well as integrations with other gateways and ingress controllers that allows you to deploy our protection at the perimeter of your Kubernetes cluster. The RASP style deployment, where you have our code essentially deployed or as a library in your application. The service mesh style deployment, where we sit as a sidecar to your application and essentially integrate with the Envoy proxy that Istio leverages as the data plane. And then for your traditional kind of perimeter-based application, which is still something that we see customers do, especially for their legacy applications in their data center. You can deploy Signal Sciences as a reverse proxy, essentially just kind of fronting all of your legacy applications in the data center. And thus we also support that kind of traditional sort of perimeter-based model as well. So let's talk a little bit about the trade-offs of these 3 different types of deployment. When it comes to the RASP style or in application, the pros are the protection, of course, is embedded in the workload, so it'll go wherever that workload is deployed. You do get the east-west traffic protection. So let's say the workload is a microservice that's not exposed externally, but only talks to other services within your application. By having that RASP style deployment, you'll get security and visibility into any attacks that might occur east-west. So north-south, of course, being traffic that flows from externally outside your organization into your infrastructure, wherever your infrastructure might be, whether that's in the cloud or on-premise. And then east-west, of course, is that traffic that happens service to service within your cluster, and that's more common, of course, with microservices architectured applications. The cons are this may require code changes, so this is just some additional burden that would be placed upon the development team, which for some organizations is not something that is desired. More management complexity, because you'll have to be managing this protection on a per workload basis. There's also more overhead than the ingress of software perimeter model, of course, because this means that you're essentially running an agent per workload. With the mesh style deployment, kind of like RASP style, you get the east-west traffic protection. It's less management complexity than RASP because you can leverage that control layer provided by Istio, if Istio is what you're using, or the control layer of whatever service mesh you might be using. No code changes. So in the case of Signal Sciences, our agent is a standalone agent that talks to a module, and in the RASP style deployment, that module is what's implemented in code. But with Mesh, there's no need for a module because our agent can talk directly to the Envoy proxy, which of course comprises the data layer in the Istio service mesh. In terms of cons, there's more overhead than the Ingress model, because again, you're going to be running an agent for every workload within your cluster that you are protecting. But that can be managed by selectively deploying the agent only on the workloads that you feel perhaps carry the most risk. And of course, it requires service mesh, which introduces a whole additional level or layer of complexity to Kubernetes, which is already fairly complex. And then in terms of the ingress or software perimeter, in terms of pros, there's less overhead. And by overhead, I mean compute and memory resources. So less overhead than the other options. There's also less management complexity than RASP or even Mesh, because you're essentially just deploying the protection at the ingress to your cluster. So you don't have to worry about deploying that agent or the protection on each individual workload as a sidecar or whatnot. And there are no code changes similar to Mesh. However, in terms of the cons and the trade-off there, in terms of the less overhead required in this deployment method, you lose out on that east-west traffic protection. So an example of that would be perhaps a server-side request forgery. An attacker might be able to leverage such a vulnerability in your application to send a malicious payload through some externally exposed container to another container within the same cluster. Also, ingress in the Kubernetes world is kind of rife with options at the moment. There are just a lot of different solutions out there, and not all may be supported. Okay, automating. So moving on to our final segment, automating container-friendly app layer protection. So how do we actually accomplish this in the real world? And I'll take you through an example of how we actually do it at Signal Sciences. So this is just a pretty basic architectural diagram of the Signal Sciences next generation web application firewall. There are components, a module and agent that sit with your applications and APIs, which talk asynchronously to our cloud, which delivers things like updated rules, threat intelligence, and so on to the agent. We're just going to focus in on the module and agent, though. So when it comes to the RASP style deployments with Signal Sciences, you're instrumenting your application with a module, which simply intercepts HTTP requests and passes them to the agent. The agent will then do all the decisioning, and it does it locally. So asynchronously, it will get updated rule sets from the cloud, but use that locally cached set of rules to decide whether or not that request is malicious and block it, or if it's not malicious, let it proceed. So the agent does the decisioning, lets the module know if that request should proceed or not, and then the module will then either block the request if it's malicious or let it go through if it's not. So here's kind of what our pipeline looks like. So in terms of continuous integration, so during the coding phase, we add that the language module to our application code. We also have modules for web servers like Nginx and Apache and IIS and so on if you don't want to instrument your code. But at Signal Sciences, we use the Go module for our web applications. We then run the application, the code through a series of automated unit tests just to ensure that language module hasn't broken anything and that any new code changes doesn't conflict with that module. And then during the build phase, we will build the application and create a container image, which is then pushed into AWS Elastic Container Registry, which is the container registry that we employ. And then in the deploy phase, deployment is initiated manually. So there's a manual trigger to begin the deploy. We run our applications in AWS Fargate. So we create an AWS Fargate task, which contains several containers. One container runs the application, instrumented with that language module, and our Signal Sciences agent runs in another container in that same task. And they communicate via RPC. And then finally, we run or execute that AWS Fargate task, and the old tasks will expire as new ones with the updated code are run. And we deploy multiple times a day. And with this workflow, with this pipeline, we find it pretty easy to ensure that every push that we with every deploy, again multiple times a day, that application protection is traveling with the application as it gets deployed into production. So just as a wrap, and wrapping up, here's what we covered today. So of course the perimeters are disappearing, and that's because of the portability of containers. It's easy to deploy them wherever, so we want to make sure that the application protection kind of travels with that container. Containers require app layer protection. That's because things like container breakout kind of leverage application layer attacks. Application protection needs to be tied to the apps themselves and not the hosting infrastructure. And that's because we don't want to have to deal with the fragmentation that results when you tie application protection to the underlying infrastructure, having to manage multiple WAFs, multiple rule sets, and so on. And then finally, this can all be automated because the protection is software-based. You can deploy this like any other kind of dependency within your application, and makes it straightforward and ensures that it doesn't slow your development teams down. So with that, I guess I'll hand it back to Charlene for any questions.
All right, great. We've gotten some questions in, but there's plenty of time, folks. If you have a question for Alfred, please go ahead and use your GoToWebinar control panel and submit your questions. And let's go ahead and just dive right on into what we've got. Okay, here's one. When reviewing the management trade-offs for the various container security options, it appears that monitoring traffic at the ingress controller has the least overhead. Can you go into that a bit more?
Yeah, absolutely. So that is essentially when you deploy the protection at ingress, that's oftentimes just a single agent that you deploy. Of course, that agent would need to have the proper amount of resources allocated to it to protect all the traffic that goes through ingress. But at the same time, that's usually less than the additional CPU and memory that will be required to run an agent on every pod in your cluster. So especially if the services or applications within the cluster don't have a ton of traffic, that can sometimes be a more efficient way to protect those APIs and apps and services within the cluster. So using that kind of ingress layer model. But again, the drawback there is you won't get that east-west traffic security and visibility in the cases of things like server-side request forgery, where there might be malicious requests being passed on from an externally facing application or service to an internal one.
Okay. All right, great. Next question here. What is considered to be the perimeter for cloud native apps? Is it the virtual network or IAM?
That's a great question. So the perimeter, as I've been using it in this talk, largely just means the hosting infrastructure. So I also talked about the software perimeter, but kind of putting that aside, the perimeter that I was mostly referring to was like the perimeter of your on-premise network and your data center, and then the perimeter of, say, your AWS cloud environment, and then your Google cloud environment, and so on. So that's essentially what I meant by perimeter. I know, of course, it can get a little fuzzy based on how you have things set up in terms of your resources or applications in the cloud being able to reach resources in your on-premise data centers. But in terms of this talk, the way that we've seen web application firewalls traditionally be deployed, like there aren't many solutions that we've seen out there that can protect both your on-premise and your cloud-hosted applications, and yet be tied to kind of a networking sort of construct. Instead, what we've seen be most successful is application layer protection that travels with the application, so that no matter where that application gets deployed to, it's protected.
All right, great. Plenty of time, guys. If you have a question for Alfred, please go ahead and use the GoToWebinar control panel. All right, here's our next question. Does RASP help with configuration drifts in containers from the original state in the image in registry, or is it in-memory style protection?
That's a great question. So RASP and WAF. So I'm primarily in this talk speaking on application layer protection. Of course, configuration drift and ensuring that your images are signed and making sure that you do vulnerability assessment to make sure you're aware of and have remediations for known vulnerabilities in your included dependencies and libraries of your containerized applications is important, but it's something that's kind of out of the scope of this talk. So RASP is really designed more to deal with the application layer attack. So like think about the OWASP top 10, like SQL injection, cross-site scripting, cross-site request forgery, and so on. However, there are other solutions, so like container security solutions like Twistlock and Aqua that are also agent-based, I believe, that can help you with things like configuration drift, vulnerability assessment of your container images, and so on.
All right, great. Next question here. Let's see. To avoid risk of a container running as root, are there default image settings or configurations that can be used to minimize this risk? And any other default configuration recommendations to prevent an attacker pivoting from a container to another resource on the network?
Yes, so essentially what it boils down to is just being very aware of all the configuration options that are set in your YAML files, essentially, and in your Kubernetes YAMLs. So making sure that privileged is not set for your containers, making sure that they're not run as root. Oftentimes, folks who are fairly new to Kubernetes will just kind of use whatever default configuration options are there. And that's often what leads to these misconfigurations that can lead to a container breakout. So it's really just kind of just being very careful about what goes in those YAML files and knowing exactly what each option either enables or disables.
Excellent. Okay. All right. Let's see. Here's a good one. If we are already using WAF from the cloud vendor, is there an overlap or can it work with the WAF? Are there any conflicts?
Sure. So we at Signal Sciences, we do have customers who employ multiple WAFs, so kind of almost a defense in depth strategy. Just kind of, and it's interesting. Because Signal Sciences detection is not based on mod security. The detection is inherently different. How most other WAFs work. We'll often catch things that go through the first WAF. I would say that it's there is, having that is of course an explicit choice that you're going to make that will again kind of lead you to this problem of managing different tools, different rule sets, and feature sets, and so on. But that's something that our customers are okay with because they want that additional layer of protection, and perhaps they get their cloud hosted WAF for free or for a minimal charge because perhaps they own another product from that same vendor. So, but yeah, it's usually kind of overlapping, and really again, like I said in the webinar, in the presentation, we often see our customers deploy different technologies or different WAF technologies based on the hosting platform. So that's usually like an Imperva or something like that for their on-premise stuff, AWS WAF for AWS, Google Cloud Armor for Google Cloud, etc. But they're starting to explore ways that they can deploy Signal Sciences across all those different hosting environments to get that unified view or single unified WAF policy.
All right, excellent. Okay, next question. What would be a best practice to automate perimeter controls for containers in the cloud?
The best practice to automate perimeter-based controls for containers in the cloud. So this would be, I would say, leverage automation. So like my example in the webinar, using a solution that can easily kind of integrate with your DevOps pipeline, something where there are either deployment styles that allow you to deploy the protection as a module or agent within the code or adjacent to the code, making sure that this protection is container friendly, can run in your containers, etc. And then during the deployment process, again, just ensuring that this, like the software-based WAF or web application technology or protection technology, can be automatically deployed to that application regardless of where it's hosted.
All right, we have, let's see, 2 more questions here, but there's plenty of time. Guys, if you have a question for Alfred, please go ahead and use your GoToWebinar control panel and submit it, and we'll hopefully should be able to get to it. Here's a question. What can I do from a developer's point of view to reduce risk when implementing code for containerized apps?
Sure. So I actually I'm a believer in developers just kind of isolating the security mechanisms within your application in such a way that the developers don't have to worry about it so much. Developers, in my opinion, should really be hyper-focused on the business logic of their applications and less so on the security aspect. I think that the SREs or the folks in operations are probably the ones better suited to be worried about the security. But when it comes to, and of course that the way that works with the whole DevOps pipeline is perhaps the SREs are the ones that are configuring the Kubernetes YAMLs or configuring the service mesh and so on. But as someone who used to be a developer, I guess I'd recommend that like when you're pushing your application into the cloud, of course you want to be aware of the best coding practices and secure coding practices, and making sure that there's input validation and just inherent mechanisms within your application to prevent successful SQL injection or other type of code injection attack. But I would say that developers should just be aware and curious of the options out there for protecting web applications. WAF is something that perhaps is thought of as kind of like an old and perhaps not so effective technology. However, there are newer technologies that provide a lot of the same benefits and really deliver on the promises that WAF kind of failed to deliver on in the past, but are also a lot more developer friendly, meaning it's easier to automate the deployment, it's easier to integrate them into your applications, and so on. And just making sure that having secure coding practices in mind, but also having that layer 7 application protection will just kind of give you additional peace of mind that your application will not be victim to an attack.
Alrighty. All right, looks like we have one more question here. Regarding getting visibility into east and west traffic between services, what other kinds of attacks can Signal Sciences detect? Are there any, are any specific to containerized apps?
Sure. Server-side request forgery is one, especially the one that was used in the Capital One breach. So any server-side request forgeries that try to contact the AWS metadata service, that's something that we can detect out of the box. But we also have a very flexible rules engine that can be used to also detect other sort of east-west attacks, things like LDAP injection, any attacks essentially that where some malicious payload is delivered through some external facing service to an internal one.
Okay, all right. Excuse me. Okay, well, looking here, and it doesn't look like we've gotten any more questions in. So with that, I'm going to go ahead and close out the question and answer period. And I do want to thank everybody who did submit questions. Great questions, guys. Let's see, if any come in the next minute or two, then we can certainly revisit them. But for now, I did say at the top of the hour that we would be doing a drawing for two $50 Amazon gift cards. So without further ado, let's go ahead and do that. Looks like our first winner for today's drawing is Mike P. Congratulations, Mike. And our next winner is Mia M. Congratulations, Mia. Mike and Mia will be contacting you via email after today's webinar to get your $50 Amazon gift card to you. So congratulations to you both. Also want to remind the audience that today's event has been recorded. So if you missed any of the webinar, or if you just want to watch it again, you will have the opportunity to do so. We will be sending out an email after today's webinar that contains a link to access the webinar on demand. The webinar is also going to be living on the devops.com website, so you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. Let's see if we've gotten any other questions, and it doesn't look like we have. So again, thank you to everybody who did submit questions. And Alfred, thank you for such a great presentation. Lots of good information contained in. So congratulations to you, and thanks so much for a great presentation.
Thank you, my pleasure.
Great. Also want to thank the audience for joining us today. I'm going to give you 10 minutes back in your day. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody. Stay safe.